Hello, in this video we will see how to find the derivative of sine x by first principles. So before we dig in, if you have not subscribed to my channel, this is a great time to hit the subscribe button. Please make sure you like the video and then share it on as many social media accounts as you can. So let's go ahead and find out the derivative of sine x by first principles. So first thing we do is we first write down the definition of our derivative. F prime of x is limit h tends to 0 f of x plus h minus f of x over h, and apply that to our function sine. So f prime of x would be limit h tends to 0 sine of x plus h minus sine of x over h. Now we need to get the expansion of sine x plus h before we can move on. So we remember that sine of a plus b is equal to sine of a cosine of b plus sine of b cosine of a. And if I replace a by x and b by h, then I get sine of x plus h equals sine of x cosine of h plus sine of h cosine of x. So we're just going to replace sine of x plus h by sine x cosine h plus sine h cosine x. And there we have it. Now in math we can often add and then subtract the same quantity depending on where we are headed. So here I just rearranged the terms. So if you can see, I put the minus sine x from being the last term to being the second term. So I've used the commutative property, and then in the next step I have factored sine x from the first two terms. So I have sine x cosine h minus 1 plus sine h cosine of x over h. So continuing with algebra, I will split this limit into a sum of two limits. So remember that if I have one limit which is the sum of two limits, I can split it into two separate limits. So, and then when there's a product, then I can also split that into two more limits. So each of those parts has now been written as a product of two limits. So now from starting from having one limit, we are at four limits. So the limit that we need to figure out here is limit h tends to 0 cosine of h minus 1 over h. And if we can figure that limit out, then we would have our answer here. So that limit happens to be 0, and of course limit h tends to 0 sine of x is 0, and then limit h tends to 0 sine of x is equal to sine of x. Limit h tends to 0 cosine h minus 1 over h will be 0. We'll see that in a minute. And then limit h tends to 0 sine h over h is equal to 1. And limit h tends to 0 cosine of x would just be cosine of x. So this means that f prime of x is equal to cosine of x. So at this point we do have our answer. We know that if f of x is equal to sine x, then f prime of x is equal to cosine of x. But before I move on, I just need to make sure that you understand why is limit h tends to 0 cosine h minus 1 over h equal to 0. So we go to the slide here, and we are trying to figure out limit h tends to 0 cosine of h minus 1 over h, and we can multiply and divide by cosine of h plus 1, and that will give us limit h tends to 0 cosine of squared of h minus 1 over h times cosine of h plus 1. Now cosine squared h minus 1 is actually equal to sine squared h plus cosine squared h. So if you remember the trig identity, sine squared h plus cosine squared h is equal to 1. So I substitute that in there. And if I just go on with the algebra, this will leave me with negative sine squared h over h cosine h plus 1, which I can write as a product of two limits. And when I write that as a product of two limits, then I know that limit h tends to 0 sine of h over h is 1, and limit h tends to 0 sine of h is equal to 0, and limit h tends to 0 1 over cosine of h plus 1 is equal to 1 over 2. So I have my limit h tends to 0, cosine of h minus 1 over h is equal to 0. So I have given you the derivative of sine x, and I've also given you the limit h tends to 0, cosine of h minus 1 over h. So we now have our results. So here's the first principal derivation of f of x is equal to sine x. So again, if you have not subscribed to my channel, please do subscribe and like and share this video, and have a good rest of the day.